Hi, welcome to Clarity OSS Reserve Facility presentation for fixed line services. This video, we're gonna walk you through the reserve facilities scenarios for fixed line services using Clarity Web Services and Inventory OSS Suite. Clarity has three main components that handle identifying resources. It's address serviceability, reserve facility, and create circuit. Address serviceability is the mapping between an address and a piece of equipment, the serving equipment. Typically, this is either a network element or frame, for example, a distribution point, located near the customer premise. Address serviceability is a mandatory capability in identifying resources. Reserve facility is an algorithm for finding network from the serving equipment specified by address serviceability back to the exchange network element, typically a voice switch, port or DSLAM port. A reserve facility looks for network that is compatible with the service type and identifies where cross-connects, for example jumpers, can be created across frames, distribution cabinet, PCP or main distribution frame. To provide end-to-end connectivity either across physical media, pair in cable, or across bare circuit. Essentially, reserve facility traces back from the serving equipment, examining resources on the route for compatibility between port, pin, and service, and availability, for example, spare or used. Reserve facility is used to find and reserve a road, essentially creating a pseudo circuit. If the reservation is not required, it can be cancelled or extended. Create circuit is an automated build of logical network across a set of resources. The resources must already have been reserved by reserve facility. The type of circuit created will depend on the type of the service requested. Reserve facility and create circuit can be replaced by manual circuit design screens in Clarity in those situations where the user wishes to create a circuit without any automation. The key component in facility reservation, in identifying resources, is the facility reservation. It extends GUI-based hop-by-hop routing. It supports pre-qualification, reservation assignment, and provisioning. It uses generic routing algorithms based on network topology and hierarchy rules. It's expandable to include customer-specific rules, and it has around 40 predefined scenarios. So during this presentation, we will try to reserve resources on the network for example, simple POTS line or POTS plus ADSL services. So we will try to demonstrate during this presentation how Clarity's reserve facility functionality is working and is trying to reserve all resources across the whole network to build, for example, POTS circuit or POTS plus ADSL circuit. So one of the key components used by reserve facility is address serviceability, which is defined through this form where a user can provide mapping between the network equipment or a frame container and the address. A reserve facility algorithm can be invoked from three different places. One is through web services exposed by the Inventory Suite module. Another is from the Service Manager workflows, and the third one is through the database procedure if needed. During this demonstration, we would like to focus on a way when it's invoked through the web services. So we will try to simulate whole interaction between, for example, CRM system or BSS systems, which might be using Clarity Inventory Suite as a backend system to reserve facilities for requested services. Clarity System Connect web services are allowing to integrate Clarity with any external system which can invoke SOAP-based web services. So, for example, here we have a set of all Clarity web services which we can invoke from external system and perform any kind of actions in Clarity. To simulate integration between, for example, CRM and Clarity Inventory Suite, we will use SoapUI tool, which allows us to execute web services deployed on our demo environment. As we can see also here, Clarity has a lot of different web services which might be invoked for different purposes and required actions. It only depends on the business scenarios which should be implemented and what kind of web services should be used for maintaining or querying the inventory manager in Clarity. So for example, we can execute any kind of actions, but in our scenario we will mainly focus on the address management services and also on the inventory management services, which we will use subset of them to present how Clarity can reserve facilities for the specified scenarios, which we will try to walk through. And the one will be reserve facilities for PSTN service at customer's address, and the second one will be to reserve facilities for PSTN and ADSL services at customer's address. So in our two scenarios, we will mainly use 4 different web services, which is get address list, reserve facility NGN, extend reservation, and cancel reservation, which will simulate interaction between, for example, CRM system and Clarity OSS inventory suite. So just to show you how many different web services Clarity can provide for invoke any kind of actions and invoke either by external service or also sent to external service. Different requests, for example, during the workflow processing as well. Now, to prepare data for those two scenarios, which we will use by invoking those web services, I used Facility Query module from Clarity Forms, from Clarity Inventory Suite, which allowed me to view facilities available for providing a service in particular area. So either we can use Nate Bauer's phone number to check what kind of facilities we have in this area of this number, or we will use location address tab to get the proper, to see how we can provide data for this first web service get address list. So now let me just go back to the previous screen. So we will try to first in the first scenario to build simple POTS reserve simple POTS circuit. So we need to identify the customer address which we will use for this scenario. To do this, we will try to use Facility Query module, where we will type the address and see if if at this address we can have any services provided. So let me now go back to the Facility Query module and we'll provide the address. So before we move on, let's verify if our address can be serviceable. So let's verify this with the in Facility Query module. So just to we will provide all address details in this section here. Of course, all the values here can be also provided through LOV list, which can be accessible from here. So first user has to click on the specific field and then press LOV button to populate all needed fields. So once we prepare this data, we will try to see if we have free network resources to provide the service at this address. As we can see here, and in the frame appearance sections, that we have some free network resources to provide the service. So we will try to now move to the SoapUI to the next steps to get the address ID. So so we are providing all the addresses, all the address details from this based on this form which we received results, and so we will try to get the address ID. So this will simplify all next subsequent steps here. Instead of providing the whole address, all address details, we will just provide the address ID, because API can either take the address ID or all other address details. So let's try. So as we can see, we received the result. So we, instead of providing all those attributes in all subsequent steps like 1, 2, and 3, actually especially 1, the first one, we will use instead of this only address ID to simplify the execution of the next web services. So we will take this, and then we will try to reserve facilities for our pod service. So for this web service, we are providing address ID from the previous step, service type pods, as as it was specified in the scenario, a reservation ID, which usually is generated by external system like CRM or BSS. In our scenario, we are trying to simulate interaction between CRM, for example, system and Clarity Inventory Suite to reserve facilities for service requested by the customer. Circuit speed we are just providing not available, which is the correct value for this in this scenario, and some specific service features which we would like to also be able to provide to the customer. So now we will try to run this this web service to see if we are able to build and reserve all the needed resources on the network. So after some time, we are receiving the results that the Reserve Facility API finished its job, and we know that it was successful because we received code 0 and some other details about the exchange. So now we will try to verify if this Reserve Facility activity has been executed properly in the inventory suite. So it means also that we have already built circuit which will now verify if it's in proper state and has all required cross connections. So in this case, we need to take the reservation ID and move to the Clarity forms. So once we have a circuit design form, we just need to search for this circuit by providing the reservation ID as the display name of the circuit. As we can see that our circuit has been built and it's in status reserved, and it has all required cross connections. And also we have a comment that it was built by the API, checking this comment here. And the service type is pods, and location A and location B, which is the beginning and the end of the circuit. Now we will try to verify also other components of the circuit, like all cross connections and if all the ports and frame appearances are in the correct state. So in this case, we will try to first verify, for example, main distribution frame by clicking. So now if we will click in the location field, we will make a double click. We will see that the frame window appeared, and in the frame appearances sections we can see our circuit that this port in the frame appearance is already reserved by this by our circuit. If we will double click on the status field, we will also see that what circuit is occupying this port. The same thing we will do for the exchange part. So now we will do the same thing for the exchange. So we will double click on the location and we will try to open the network element form. So once a network element, So we can see also that once the network element form is open, we can see that this port is used by our circuit, and once we will double click on the status field, we can see more details about it. So we can see which circuit is reserving this port. In other tabs, we can also see other details about the port used by our circuit. For example, in the connections, how the port is connected to other network elements, like to frame container or to frame unit. So as we can see, all required resources have been properly allocated for our circuit, and now we will try to in the next step we will try to extend the reservation period for the circuit. Now, before moving to extending the reservation period for the circuit, we will verify what is the current one, and we can do this by clicking on the tool palette button and checking the view reservation details option. So we can see that our expiration date is set for 1 month in advance, and we will try to change it using the Clarity Web Services. So in this case, we will open the second request, where we will change the date to so for example, we will try to extend the circuit reservation by the next 2 weeks since the date which we checked in the forums, which will be around 24th, for example, of June, and we'll try to run it. Once we receive the response from the Clarity Web Service that the expiration date has been modified, we will now to verify if this is as expected. So we will one more time go to Tool Palette, we will see the View Reservation Details, and as we can see here, the date has been modified to the new value. After that, we will try to execute step, for example, to simulate scenario where customer is resigning from the reserved circuit for his service, and whole reservation has to be cancelled. So all the network resources will be unreserved and will be one more time available for another reservation. So in this case, we need to run the third API, which is cancel reservation, which is simulating interaction, for example, between CRM and Clarity inventory in case customer resigns from the reserved circuit for his service. So in this case, we need to only provide the reservation ID and run the request. Once we receive the information that web service has been executed, we see that cancellation was successful. Now we will verify it in forms. So we need to just check one more time if our circuit is still available. And as we can see, we received information that there is no circuit already. There is no circuit and it has been cancelled. So we can say that the first scenario has been completed, and we will move to the scenario number 2, where we will try to reserve resources for PSTN and ADSL service. For this scenario, we will execute similar steps, but we will slightly modify the request for reserve facility, because we will add service type ADSL, and also will provide circuit speed and different reservation ID. So we will now execute this request. And as we can see, after some time, the web service has completed its job successfully. So we will now try to verify if the circuit and all required resources were reserved properly. So in this case, we will one more time go to the circuit design form, and we will try to find this circuit and all its details. So as we can see, circuit has been created by our web service. It has all required cross connections. As we can see on the form, we already have we found the pod circuit, and also Reserve API created also circuit for ADSL part. But as we can see, we have a Bera circuit, which is storing the common infrastructure. And here on the diagram on the left side, we can see that POTS plus ADSL circuits POTS plus ADSL services are POTS plus ADSL circuits are modeled in a way that common infrastructure between the DP and the DSLAM parent port POTS out is modeled on the Bera circuit. And also, to model this whole scenario, the reserve facility is creating automatically for also network element called the DSL splitter, which contains 3 ports. When we will check this splitter, we will see that it has a parent port called POTS out, which supports ADSL service, and as we can see, it's the Bera circuit is using it. It has also DSL port, which is a child port, which supports ADSL service. And it also has a child port POTS in, which supports POTS service. Now we will try to see how POTS circuit look like. So ADSL is a child of Bera circuit, and now the POTS circuit is modeled that it's a connection between DSL splitter and exchange. As we can see also in the cross connections, the connectivity between DSL splitter and the DSLAM is only modeled as a logical connection, and the common infrastructure between the DP, distribution point, and the DSLAM port is modeled on the Bera. Now we will see this one as well. As we can see in this form, the ADSL Bera is modeling the part between the DSL splitter and a DSLAM network element, and it contains also two tributaries, which is the POTS and ADSL. As we can see also, we will check also the DSLAM network element. And as we can see on the next form, the port pots out underscore 27 contains is reserved for is used by bearer circuit, and it contains two child ports, DSL and pots in, which are used by ADSL service and pots service. So the port pots in supports POT service, and the DSL supports ADSL service type. In other tabs, we can check, for example, if a port is physical or logical one. If it's physically connected, means set to yes, it's a physical port. And in the connections tab, we can check, for example, to which to check the ports directly connected frame container or frame unit. Same for the, the same information for the parent port and for the child port. Now we will try to. So this is the way how POTS plus ADSL circuits are modeled in Clarity Inventory Suite. And now we will try to move to the next steps of the scenario, where we will try to extend the reservation period for POTS plus ADSL circuit and also cancel the reservation. So as we can see, this is the reservation period for the bearer circuit. This will be the reservation period for POTS. They are the same. And we will also check for ADSL. Now we will try to modify this reservation period. By setting into some date in the future. So once API return response that it successfully updated the expiration date, we will now verify if for all circuits the expiration date has been set to value in the future. So we will now check the ADSL bearer circuit, and as we can see, there is new expiration date for the circuit. We will do the same for two other circuits. So as we can see, for POT circuits the expiration date was also set. And now we will verify it also for ADSL. And it's also. So now we will move to the next step of this scenario, where we will cancel the reservation for all circuits and for all facilities. So in this case, we have to use API cancel reservation, which would be normally invoked from CRM or any external system to cancel the reservations in Clarity Inventory Suite. As we received a response message from the web service that a reservation has been cancelled, we will now verify if all the circuits were removed. Okay, so for this we will open new form. And now we will check one by one using the reservation ID or as we can see, the ADSL Bera circuit has been successfully removed. Now we will verify also. Now we will verify also two other circuits. As we can see, those two others for POTS and ADSL has been also removed. So one more time we'll just double check. And as we can see, two other circuits were also successfully removed, so the whole scenario has been completed. And that was the example how Clarity can be integrated with other external systems using its web services library. Thank you for your attention and goodbye. So